Hi class, today we're looking at Chapter 5, Lesson 9, Similar Figures. We will be learning how to find missing measures of similar figures and how to use scale factors to solve the problems. Some vocabulary terms we need to know. Similar figures are figures that have the same shape but not necessarily the same size. If two figures are similar, then the corresponding angles are congruent. So let's emphasize that the angles are exactly the same or have the same measure. And the corresponding sides are proportional and opposite of the corresponding angles. So in this case, the angles have to be congruent, meaning exactly the same. And the way we look at congruency is we would write this as congruent. Then if we say that the corresponding sides are proportional, that just means that each one of the ratios has to be equal to each other. Now, similar figures have corresponding parts. Corresponding parts are meaning similar. So when you hear the word similar, then that means they share something in common. These could be the angles and sides in the same position, but not necessarily always the same exact measurement. It could be and it might. It just depends on the actual image. So when we're thinking of the corresponding parts, we have two examples here. We notice that the angles are going to be exactly the same. So the angles are 40 degrees, 40 degrees. Then we notice 70 and 70. So all the interior is exactly the same. But we do notice that the exterior, the side lengths, are different. One is larger than the other, and therefore we know that the outsides are not exactly the same, but we can prove that they are proportional. So their angles are congruent. So the way we would say this is if we look at angle K, so I have angle K is congruent to angle E because they are both 40 degrees. And since they are both the exact same measurement of degrees, we call them congruent. But now, if I were to look at the side length, so if I were to look at the side of K to M and then the side of E to G, they are similar to each other. So if I were to go side KM is similar to side EG because they are not the same exact measurement, but they share the same proportional relationship if I were to set up a proportion. So if I were to set up KM and it's the same as EG, then I know I can go 4 centimeters over 2 centimeters. And I could set it equal to another side length. So I could set it up to the side length of ML and GF. So ML is 2 centimeters and GF is 1 centimeter. So what I just do is reduce my ratio to make sure that they are proportional. So I could use cross product and go 4 times 1, which is 4, and 2 times 2 is 4. So since they are equal to each other, they are proportional, meaning they are similar corresponding parts. Go ahead and turn your notes over to the back side now. Now let's go ahead and try an example. So in example 1, we have the missing value of x meters. So this side length, E to F, is supposed to be similar to the side length of B to C. But since we don't know the value, that would be a ratio we don't have. But we are given the side length of B to A and E to D. Since you are given two side lengths that are similar, corresponding to each other, we can actually set up a ratio. So since they are similar, we're going to go 4 meters over 6 meters, and it's equal to the potential ratio of 12 meters over x meters. Now I can use the cross product, which I've already learned how to solve a proportion and multiply diagonally. So 4x equals 12 times 6, and that gives me 4x equals 72. I go ahead and I divide each side by 4, so x would equal 18 meters. And once I've gotten the 18 meters, I can go ahead and set up the proportion to make sure that they have a similar proportionality by reducing their fractions. So 4 over 6 simplifies to 2 over 3. But now I have to make sure that 12 over 18 also simplifies to 2 over 3 to make sure that they are proportional to one another, making them similar figures. So I can divide the 12 by 6 and the 18 by 6, and I also end up with 2 over 3. And since they both have the same reduced ratio, that makes them proportional to each other. Therefore, they are similar figures. And x, therefore, can be 18 meters. Now, in example 2, we are looking for the value of x kilometers on side length UW, and the matching similar side length would be AB, which is 9 kilometers. But we are given the ratio of A to E and U to V, so we're going to use that. AE is 11 kilometers, and U to V is 44 kilometers. And we're going to set that equal to the 9 kilometers over x. So now we're going to use the cross product. 11 times x is 11x, and then 44 times 9. So we have 11x equals 396. Then we'll divide each side by 11, and x would equal 36 kilometers. And that is our missing side length of WU. Now, to make sure that we do understand that they are similar side lengths, we can set up the ratio of having 9 over 36, which simplifies to 1 over 4, just like 11 over 44 also reduces to 1 over 4. So if we notice that they both reduce to the same value of 1/4, then we know that they are similar corresponding figures. Now, in example 3, we are going to see that we are still evaluating for our value of x. Now, we notice that the side length U to V is similar to the side length of P to O. So since they are similar, that is how we would set up our ratio for them. But we are given the ratio of O to R and S to V. And since they are given to us, we are going to write the 6 inches over 32 inches since they share that similar length and create the ratio. Then our other side length, we're going to have 3 inches over X. And that's what we're trying to evaluate. So in this case, we are going to multiply using the cross product. So 6 times x is 6x, and then 32 times 3. So we have 6x equals 96. Divide each side by 6, and x gives us a value of 16 inches. And the 16 inches represents our value of x and our missing side length. Now go ahead and practice these 3 got it problems on your own.